The inquiry into what preceded the Big Bang has sparked discussion and interest. It's been a big mystery for a long time, not only about how we might comprehend the universe, but also about the boundaries of human knowledge. Imagine standing on the edge of everything, considering what was there before the universe began. The Big Bang signals the beginning of everything we are aware of: space, time, and matter. But could there have been something before it? Could there have been a time before this incredible event? And if so, what was it like? As we explore this question, science takes us on a journey into challenging concepts about what we think we know. Famous physicist Brian Cox, who's known for explaining the universe's wonders, suggests that it's possible something amazing existed before the Big Bang. He asks us to think differently about reality and existence. In this discussion, we'll break down the science and ideas that might help us understand what came before everything we know. We'll look at theories about quantum changes, dark energy, and even the possibility of multiple universes. The responses might be unexpected, and they could change the way we understand our place in the universe. Let's investigate a world beyond imagination, where mysteries still puzzle scientists and at times leave them questioning everything. To understand what existed before the Big Bang, we first need to know what the Big Bang was. Scientists call it the moment when the universe became extremely hot and compacted, rapidly expanding and starting the creation of energy and matter. When we look at the stars and galaxies today, we see signs of that hot beginning as galaxies. Start small and grow outward. But why did this happen? And was there anything before this hot start? As suggested by the theory of cosmic inflation, before the Big Bang, the universe was cold, empty, and void. But this emptiness wasn't completely empty. It had a lot of energy, resulting in the rapid expansion of space itself. This rapid growth, called inflation, happened so fast that it set the stage for everything that came after. This expansion slowed down, and the energy turned into matter and the forces we see as the Big Bang. But where did this energy come from? And why did it suddenly make the universe? Some scientists consider that the inflation occurred in patches of the universe, each with its own Big Bang. Picture a fabric stretching endlessly, with bubbles forming here and there, each bubble representing a different universe, including our own. This idea, called the inflationary multiverse, hints that there could be an infinite number of Big Bangs and universes. Our own universe is just one of many. This mind-blowing idea challenges our conceptualization of the universe and raises the question, what else is out there? The idea that there was nothing before the Big Bang is speculative, not based on facts, but even if you removed all energy, particles, and radiation, the universe would still not be completely empty. Space is filled with dark matter, dark energy, and quantum fields, forces and energies that make up the fabric of everything, even when it is empty. Despite our fantasies of removing all these forces, space would still have new kinds of energy. This alone is puzzling for scientists, as it suggests that true nothingness may be impossible. Space itself has qualities, rules, and constants that prevent it from being totally empty. Imagine a region with literally nothing. No particles, no energy, no radiation. Just quantum fields and constants would continue to exist in these fields, meaning even this nothingness has properties. One such property is called zero-point energy, which is the lowest possible energy level of quantum fields. Even at this state, particles can suddenly appear and disappear, creating a strange way of doing things, even in what should be empty space. This challenges our idea of nothingness and suggests that even before the Big Bang, there might have been something that researchers are still attempting to understand. One of the most surprising ideas in modern science is the concept of eternal inflation. If inflation could create our universe, it might continue forever. Brian Cox talks about a huge, infinite, inflationary multiverse in which universes are constantly being created and expanding. Imagine each Big Bang as a spark that starts a new universe. As long as there is inflation in other areas, it creates countless other universes. This process could, in theory, go on forever. This idea of new universes is fascinating, offering the possibility of a fractal universe where each new universe creates its own Big Bang. Each universe would be separate, not affected by others, because space is expanding so quickly. For scientists, this idea is exciting and unsettling because it suggests that the universe has no real beginning or end. Consider our universe as a mere fragment of a much bigger, endless design, always expanding and creating new universes. What if the truth is that there is no beginning or end, but rather a never-ending cycle of universes being born and dying? The way we think about quantum effects is based on quantum field theory. The universe isn't just a collection of matter floating in space. It's a complex network of energy fields that interact to create everything we see. These fields are like invisible oceans, with particles acting like waves or disturbances. Even when these fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, taking energy and then returning it. This leads to virtual particles, particles that exist only briefly before vanishing, leaving only a faint trace of their existence. The idea of virtual particles challenges the concept of complete emptiness. Imagine a totally empty universe, devoid of matter and energy. You might think you really have nothing. According to quantum field theory, no, you would still have fields that are constantly active, sometimes producing such particles. This constant activity in what should be empty space shows that the universe doesn't recognize our idea of nothing. These fields and forces keep going, bringing hidden energy into the space that stops complete emptiness. This brings up an interesting question. If fields create particles and particles create matter, could the universe itself have come from this nothing filled with quantum fields? Dark energy is a mysterious force that is causing the universe to expand faster and faster. But did dark energy exist before the Big Bang? Some scientists think that the dark energy we see today could be the leftover energy from before our universe began. The properties of dark energy seem to point to a powerful force that might have existed in some form before the Big Bang. According to some theories, dark energy, in a stronger form, might have driven the rapid expansion of the early universe. The fact that dark energy exists hints that even if everything, matter and radiation, were removed from the universe, this force would continue to stretch space. This idea raises a troubling question. If dark energy existed before the Big Bang, could it have caused the conditions that led to the creation of our universe? As we think about this possibility, we face the idea of dark energy not just as a force shaping our universe, but as a key to understanding the multiverse itself. Another theory is cyclic cosmology, which offers a different view of the Big Bang. Instead of seeing it as a one-time event, it suggests that the universe goes through endless cycles of birth, death, and rebirth. In this view, the Big Bang isn't the beginning, but only a part of an enduring cycle where universes grow, collapse, and are reborn. This theory suggests that our universe could have grown out of the remains of a past one. The cycle of expansion and contraction means that there was never a true beginning, but an eternal sequence of universes being born, living, and dying. Cyclic cosmology raises big questions about time, suggesting that time might not be linear but cyclical. If this theory is true, it means that what existed before the Big Bang was just another version of the universe, one that ended and gave birth to our universe. For scientists, this idea offers a satisfying response to the question of what came before, indicating that the universe has always existed in some form beyond our ideas of time and existence. Gravitational waves are another exciting concept that could help us understand what took place prior to the Big Bang. These waves, predicted by Einstein's theory of general relativity, were later detected, showing that our universe has deep, vibrating movements. Gravitational waves could, in theory, let us look back further in time than ever before, possibly even beyond the Big Bang. They could give us clues about the events preceding the universe's start, showing if other forces or even other universes affected how ours developed. Scientists hope gravitational waves will provide evidence from the time before the Big Bang, assisting in breaking through the limitations of time and displaying a time that appeared impossible to comprehend. As we think about what came before the Big Bang, we are clearly at the edge of scientific discovery. The mysteries remain, and what we know now might be just a small part of what will be uncovered as we keep pushing the boundaries of human understanding. But the question still stands. What truly existed before everything? The answer may be more bizarre and amazing than we ever imagined. As we continue to explore the universe's beginnings and the possibilities of what came before the Big Bang, we dive deeper into the realms of speculative science, whereas a few concepts challenge the limits of our understanding. Others give us a new perspective on the ways in which the universe might have come into existence. One thing remains. Each new cycle is a new version of the universe. As science progresses, we might find answers to these deep questions. But for now, the mystery of what existed before the Big Bang will continue to intrigue and inspire curiosity. As we investigate the mysteries of what more deeply existed before the Big Bang, it's important to realize that much of the research around this idea is still highly speculative. While we can observe the universe's current structure and study its origins through the Big Bang, what truly happened before this event is still beyond our reach. This does not mean that the search is in vain. Rather, the journey itself may reveal more about the fabric of reality than we could ever have conjured up. One of the most eloquent aspects of cosmology is the role of time itself. As we know, the Big Bang symbolizes the dawn of time and space, as we understand them, so the very question of before becomes problematic. According to Einstein's theory of relativity, time and space are not separate entities, but are part of a single interconnected fabric known as space-time. This means that asking what happened before the Big Bang may be meaningless because time itself may not have existed prior to the event. If time is tied to the birth of the universe, it's possible that no one spoke of before at all. The concept of before the Big Bang poses another paradox. In a universe where space and time were created at the same time, how can we use our conventional understanding of past, present, and future? Could it be that time, whether it is cyclical in itself or not bound to a linear progression, leads us to the idea of time as a dimension that could stretch, compress, evolve, and loop without a fixed beginning? Concepts like these challenge our human intuition, reminding us that the universe operates according to laws that transcend our everyday experiences and perceptions. In the search for answers, one theory that has gained traction among physicists is the idea of a quantum fluctuation as the origin of the universe. In quantum mechanics, particles can spontaneously appear and disappear from what seems like nothing, a process known as quantum fluctuations. Could the entire universe have emerged from such a fluctuation in a quantum field? This would mean that the universe as we know it might have emerged from a nothingness that was not truly nothing at all, but a fluctuating quantum field. This view implies that prior to the Big Bang, there could have been a kind of quantum empty space brimming with potential energy, but not matter in the form we recognize today. Yet there are still even more unconventional ideas that stretch our understanding. One theory posits that our universe could have originated from a cyclical model with a big bounce, in which each Big Bang is a rebirth following the extinction of an earlier universe. This model suggests that the universe undergoes an infinite series of expansions and contractions in which the universe continually collapses under gravity, then explodes again, starting a new cycle of growth. In this view, our current universe may have been preceded by another one that collapsed into a singularity, only to produce the universe we observe today. This theory utilizes concepts from string theory and quantum gravity, but it also raises questions about what causes these cycles and how they might continue indefinitely. Interestingly, as our tools for observation and technology improve, we may one day find indirect evidence that can offer more information regarding these speculative ideas. Projects like the James Webb Space Telescope are providing astronomers with new perspectives on the universe, capturing light from distant galaxies and uncovering clues about the conditions of the early universe. By studying cosmic phenomena, such as cosmic microwave background radiation, thought to be the afterglow of the Big Bang, scientists hope to learn more about the earliest moments after the event. In doing so, they may find evidence that could enable us to examine the origins of the universe and even explore the question of what came before. There also exists the enticing possibility that advanced physics, which is still young, will eventually expose more extensive layers of understanding. Theoretical physicists are developing theories that seek to unite quantum mechanics and general relativity, which could allow us to understand conditions before the Big Bang. For instance, the theory of quantum gravity attempts to explain the actions of space and time at the smallest possible scales, where both quantum effects and gravity are significant. If successful, these efforts might one day offer a complete picture of the universe's origins and allow us to explore its pre-Big Bang state. Some ideas even entertain the notion that our universe might not be the only one, suggesting that we are merely one among an infinite number of universes in a larger multiverse. In this view, each universe would have its own set of physical laws, constants, and properties. Our universe, with its particular order of matter and energy, might simply be one of many in an endless, ever-expanding cosmic structure. This idea also leads to the possibility of parallel universes in which things unfold differently from what we experience in our universe. The idea of the multiverse could reshape our understanding of the Big Bang, suggesting that our universe is just one of countless others that have emerged through similar or entirely different processes. Despite the immense challenges of answering what existed before the Big Bang, the pursuit of knowledge continues to expand the horizon of human comprehension. As researchers continue to explore quantum mechanics, cosmology, and the fundamental forces of nature, the answers to these questions may eventually emerge. Whether we discover evidence of a pre-Big Bang universe, uncover new insights into the nature of time and space, or stumble upon entirely new concepts that challenge our understanding, one thing is clear: the mysteries of the universe are vast, and we have only begun to scratch the surface. While the question of what came before the Big Bang might never be fully answered in our lifetime, the pursuit itself highlights humanity's deepest desire to comprehend where we come from, what the universe is made of, and what forces govern the cosmos. This quest for knowledge may lead to new paradigms in science and philosophy, as we seek not only to understand the origins of the universe, but also to comprehend the fundamental principles that govern existence itself. The search for truth, however, elusive it may be, will continue to challenge the limits of human thought and scientific discovery.